to have you today, sir. Sir, this training program will focus on integrating data-driven approaches in agriculture, and the objective of this training is to equip our participant with the necessary knowledge and skill to effectively analyze agriculture data using statistical programming language using R. Sir, throughout the training program, our participant will have the opportunity to interact with renowned experts in the field of data science and agriculture. They will gain insight from their experiences, best practices, and engage in meaningful discussion to further enhance their understanding of data-driven agriculture. Sir, in this training program, nearly 400 participants registered across the country, and some international participants also registered for the training, which include faculty and students from different organizations and disciplines. I would like to express my gratitude to organizing committee, faculty members, and resource person to their relentless effort to designing this comprehensive training program. Their expertise, dedication will undoubtedly contribute to success of this endeavor. I once again extend a warm welcome to all of you to this inaugural function. Let us embark on this journey of data-driven agriculture together, nurturing innovation, sustainability, and progress in the agriculture sector. I wish you all a fruitful, enriching training program. Thank you all. Now, I request our Dean Sir to give a remark on this training about the training. Thank you.
May I audible, sir?
Yes, sir. Are you audible?
Good morning to all the participants. It is my pleasure to welcome all the participants online training program on data drive agriculture and statistical analysis. So using
Sir, please unmute, sir.
rapidly words. Vijay Kamal sir, echo आवाज.
Yes, sir, we can hear clearly, sir. You can.
Oh, okay. Agriculture industry facing the numerous challenges demanding innovative solutions is as required. So we are producing a lot of fruits, vegetables, and so many others inputs are required for producing. But at present times, it is necessary to we evaluate to exactly what inputs you use for increasing production. Statistical analysis or statistical techniques is also the way to we emphasize the which methods or which inputs are highly useful for increasing the productivity as well as production, and which extent we use these inputs. So it is a very important aspects to data drive in agriculture and statistical analysis. The training used for R to evaluate the input use efficiency for maximum DC ratio. Throughout this training program, you will be explore the power of the data drive agriculture and how to statistically analysis use in R programs, languages, and resolving the way to be appropriate farming practices, crop management, and decision making. Very important thing is our aim of this training to we make a decision, we make a particular point. This is a very important for increase the BC ratio, especially in agriculture or allied subsegments. By the end of this session, you will be also solve the understand fundamentals of data analysis and how to apply the statistical techniques. It is an urgent need in agriculture sector of India. We also into the existing fields. We will uncover the key benefits of the drive agriculture. By employing the statistical analysis, we can given valuable insights in crop performance, weather practices, disease forecasting, soil health, and many other circumstances. Those are responsible for increased productivity and production. Statistically, we analyze the each and every components combinedly as well as separately. Important for researchers and research scientists for minimizing risk and increase yield. This training program, we will also provide the hands-on examples. This is very important to understanding the drive or languages. Practical exercise using also all programs and languages also explained by our renowned or lot of experienced resource persons. Remember, in agriculture of journey, continuous learning is the improvement, and enhancing the statistical analysis, we can unlock the potential of our agricultural system and optimize the resources utilization. This is a very, very important aim of this training. I encourage you are actively participants and ask a question to our respected resource persons and collaborate. This follows a participant during the training program. Together, we also explore the vast possibility of the data drive. I expect my warm welcome to all participants, and thanks for your, I also thanks to respected speakers, those are agree in a simple request. And I also thanks to Honorable Vice Chancellor, Agriculture University, Jodhpur, to conducting this training. And I'm saying my gratitude to Dr. Kapil Chaudhary and Dr. V.K. Meena to doing excellent from last 1.5 months for conducting this full training. Thank you very much, sir.
Thank you, sir, to guide us about the training program. And now I would like to request our Vice Chancellor, Professor Dr. B.R. Chaudhary, sir, Honorable Vice Chancellor, about the sir, please.
Good morning to all you.
Yes, sir. Audible, sir. Audible.
Yes, sir. Yes, sir.
Okay. Professor R.L. Bhardwaj, Dean College of Agriculture, Sumerpur, and planner of this important training program. Organizer, Dr. Kapil Chaudhary and Dr. Vijay Kamal Meena, Assistant Professor, College of Agriculture, Sumerpur, all the faculty members and participants, either on online or offline. It is my pleasure for me to open a 5-day training program on very important topics, data driving agriculture, designed by our faculty. All relevant topics will be covered in this 5-day training program. Hope this training will be found useful for the agriculture scientists and the students. I extend my appreciation to organizing committee for their efforts in designing the program. I also appreciate all the resource persons who will share their knowledge and experience to the participants. Once again, I thank all the participants and look forward for their continued growth and success. Thanks again. Thank you, Dr. Chaudhary and Dr. Meena. Thank you.
Thank you, sir. Thank you, sir, for your words. It is very inspiring and motivate us to drive such type of training and organize such type of training. Now, I would like to request Dr. Vijay Kamal Meena for the vote of thanks.
Thank you, Dr. Kapil. Honorable Vice Chancellor, Professor Dr. B.R. Chaudhary, sir, on behalf of the organizing committee and all the participants, I extend my heartfelt gratitude for your inspiring words during this session of the Virtual Data Analysis Training Program. Your presence and insightful remarks have truly set the tone for this training, and we are deeply honored to have had the opportunity to learn from your wisdom and expertise. We also express our sincere appreciation to the Dean College of Agriculture, Sumerpur, Dr. R.L. Bhardwaj, sir, for gracing us with his presence and sharing his valuable thoughts on this occasion. Your extensive knowledge and expertise in the field of agriculture have been a guiding light for countless individuals, and your contribution to our training program has been truly invaluable. Once again, I extend my sincere thanks to Vice Chancellor Agriculture University Jodhpur and Dean College of Agriculture Sumerpur for their unwavering support and inspiring words. Thanks to all. Now, dear participants, it's my great pleasure to introduce our esteemed guest for today's online training session. We are privileged to have with us Dr. Rajiv Ranjan Kumar, scientist in the Division of Forecasting and Agriculture System Modeling from ICAR IASRI New Delhi. He brings a wealth of knowledge and experience that will undoubtedly enrich our training program. Sir have developed many R packages and thousands of beneficiaries used his packages. Sir has published many research papers in national and international journals. Sir is widely recognized for his groundbreaking contribution to developed R packages. Without further ado, I invite you all the warmly welcome Dr. Rajiv Ranjan. We are truly honored to have him here today and we are eagerly look forward to his enlightening and thought-provoking session. Dr. Rajiv Ranjan sir, the platform is yours now.
Thank you. Thank you, Vijay. A very good morning, all of you. Thank you for inviting me for the session on R and overview of R software as well as the explanatory data analysis using R software. So I want to start from some basics. I will start from the beginning, like the installation of R and how to install R Studio and how it works and the genesis of R like that. And after that I will give a real data set example and illustration for the practical point of view, how to apply R software in different area. So just I am sharing my screen. Actually, I'm not able to share my screen. Kapil, kindly enable me to share my screen.
So now you can see.
Okay. Yeah. Is my screen visible?
Yes, sir.
Now, actually, R is a very important and very versatile software in the application of data analysis, and it is a free software. And free as well as there are so much support files and R packages are available for the data analysis. Actually, R is based on S language. First of all, the S language was developed in 1993, and further, the Ross Iraka and the gentleman at University of Auckland, New Zealand, further developed the R software. So, and at present it is maintained by our development core team, and it is about the group of 20 statisticians and computer scientists. So it is also a very user-friendly software, and you can do any types of analysis using the R software. So before I go further, first of all, I want to give some how to install R and R Studio. At that time, we will install. After that, I will give some more brief about the R software. So for the installation of R software, For installation of our software, simply go to Google. All of you, I request you, all of you, kindly go to Google and simply write download our software. Download our software, not our studio. Download our software. Then when you open this one, then click on this one, download R 4.3.0 for Windows. After that, this one is the latest version of R software. Download R 4.3.0 for Windows. Click on this one. When you click on this link, then it will automatically download the .exe file. Okay. After that, you open the .exe file and double click on this one. Actually, I have already installed the R, so I didn't require the installation again. So I request all of you kindly click on this one. It will take a few minutes. It may take 1 or 2 minutes for the installation. And all of you, I request to kindly install the by default setting of R. Install this. Then this window will open. Then click on OK.
आर सॉफ्टवेयर डाउनलोड होगा फिर उसके बाद में आर स्टूडियो, ये दो सॉफ्टवेयर डाउनलोड होंगे.
What? Actually, this one is the latest version. If in your system there is an older version of R, then it will overlap them, or both the R version exist in your system. Actually, we have not the latest version of R, and there are so many R packages that support older version of R. Click on next. And one more thing, if your system is yeah, what? Problem?
दोनों मिला के definitely
Click on next. If you have a 32 version system, 32 bit system, then the requirement is 32 bit of R, and 64 system, it is installed the so when you come here, then
Sir, please mute other participants so we can listen properly.
Kapil, kindly unmute all other participants.
Sir, now you are host, sir. You can.
Yeah, okay. So click on this one next. Then leave default all settings. Then it will automatically installing the R software. Okay. Then actually kindly follow the installation process. And if you are facing problem, then you can write in chat box, or you can later contact Dr. Kapil or Dr. Vijay or me also. I will help you. After that, after installing this one, install RStudio. Then simply write in Google, download RStudio, STUDI. Okay. Download RStudio. So when you write this one, download RStudio in Google, then the first video, project, this one, RStudio desktop.
Sir, there is voice
Then-
break.
Okay. Now I am audible.
Yes, sir.
Then this one, download RStudio desktop for Windows. Then when you click on this one, download RStudio desktop for Windows, then it automatically download the .exe file of RStudio. After that, open the folder. Open the folder of RStudio and double click on this one and simply follow next, and leave all the default setting of RStudio during the installation process. So actually I have already installed RStudio. So kindly I request all of you kindly install the RStudio, because all the classes of in this training program is based on RStudio. So I will give 2-minute time for the installation of RStudio.
Sir, no voice.
Yes lah, time
Yeah,
din na niya yo. Son time din na niya gam. Hah? Oh yeah, okay.
Okay. Then kindly all of
Yeah,
you install R and RStudio.
yeah.
So when you open this one, R,
You don't know. Open by say.
Dr. Rakesh, please mute yourself.
so when you open this one, R, so this type of a screen appears. Actually, R and RStudio, actually for for the operation of RStudio, installation of R is important. If you didn't install R in your system, then the RStudio doesn't work. But the vice versa is not true. So without installing RStudio, you can work in R. But the main problem in the R console is that it is very it is little knowledge of some programming language for the operation of R. So, but RStudio is a very user friendly and easy to use and so many options are available in RStudio. So suppose that here I want to give some brief about some basic function. This one is the file. So here you can write the new script, open a script like a script. And then delete, view miscellaneous packages like etc. It appears. But if you want to do works easily in R, so it is better to use RStudio. So in all practicals, in all classes, we will use the RStudio. Actually, the RStudio is the encapsulation of R. And there are so many options in RStudio. I think that all of you install the RStudio. We have already installed the RStudio. Actually, I want to minimize the upper ribbon. Okay. So in RStudio, there are 4 panels. The first one is this one. Here you can write all types of codes, and you can store codes here. This one is the console. This one is the environment and history. Here you can see the environment and history. The working environment of the R, and this one is the last panel. You can see all the plots, graphs, packages, files, etc. Kindly wait for 1 minute. Actually, I want to minimize this one. Kapil, how to minimize the upper ribbon?
1 second. So there is a view option. In view option, you can change.
In view options.
Means RStudio, do you want to minimize or R, sir?
No, this one is the zoom upper ribbon.
Yes, sir, in the right side, upper right side, there is one option is view, sir. From that you can minimize.
This one, in this one.
Sir, one option is there, view option is there.
I'm just unsharing. Okay, no problem. I will. Okay, no problem.
प्लीज म्यूट कीजिए सर उनको बाकी को.
तो ये खुद ही म्यूट कर सकते
ठीक है. So this one is the 4 panel of the RStudio. So see here. I start from initials. So there are so many options. This one I will discuss some important functions. RStudio. After that, I will give the how these commands works. So this one is the file. In the file options, there are so many options like here from here you can add the new R script, then R project. This one is the open files. Suppose that if you have new files, then from there you can open the new files, etc. And this one is the command of import data set. Suppose that if you want to import the data set from different library, like from Excel, like CSV file, etc. Then using this command, you can import data to the environment. Then this option is used for the saving your or saving the codes in the .r. So next come to the edit. In the edit, this one is used mainly do like that, and this one is in this panel. There is no so much important. Then view. Suppose that if you want to zoom the RStudio like that, then it will zoom RStudio panel like that. Suppose that if you want to minimize the RStudio, then you can use this command, zoom out command, like that. I will zoom out. Okay. Then this one is used for the plots, and different types of plots you can use this command. So after that, come to this one, the rightmost panel of the RStudio. So here there are mainly two things. The first one is the history, and the second one is the environment. The environment means all works you have done in RStudio in the particular session comes in the environment, and all the codes which you have run in RStudio, all the codes come in the history panels. Suppose if you want to import the codes from history panel to the yours in this panel, then simply select this one and click on this one. Then see the codes come on this one. Like that, select this one and click on this one. Then it will come to the and from here you can save all the codes also. Then come to this panel. This one is an important panel for the installation of any package or plotting of data or the manipulation of any files, then help, etc. So first I will start from the files. So when you click on this one, files, then there are so many files appear in your system or in the R environment. And from here also you can do you can select the working directory also. Then second come to the plot. This consoles if you have plot any plots in RStudio, then all plots come in this console. In this area. Then come to packages. So one of the basic function of the RStudio, or one of the basic thing for the running any types of code in R or RStudio is the installation of package. From here you can install any package or you can update any package. I will show how to install any package in R or RStudio. So next come to the help. So in this panel, the help file come for if you want to take help, suppose that if you don't know anything about the any function, then simply write the some small basic command, then the help file open in this panel. Then this one is the viewer, then presentation. These two are not so important, but these four are important: files, plots, packages, and helps. So first, I will start from the different data types in the R. So, like the other programming language, R also supports almost all data types and very in very user friendly manner. So, the data types may be vectors, logical, numeric, or vector, list, matrices, arrays, factors, etc. So, and one of the most important thing about the R is a case sensitive language. Suppose that if you write x equals to, in R you can write equals to, or equal, or you can also use the less than dash command. Both are same. I will show. Suppose that if you write x is equal to 20 and y equals to 10. Okay. Here you can also write simple sign equals to. Both are same in the R Studio. So then when you write code this one, then simply enter control plus enter, or to put the cursor here and simply click on this one, run. Then in the console you can see one minute. When you click on this one, then here you can see it run x is equal to 20. Then I find the value of x. Then simply write x. Then put the cursor here, or you can select this one and click on this one. Then the answer become x equal to 20. Okay. Then no problem. Suppose if you write here the capital X, then you can error. Capital X not found because it is case sensitive language. R is a case sensitive language. So there is a difference between capital X and a small x. Suppose that if you write data equal, here I am writing the one here. Then click on, then object data become created. Actually, this one is the object. You can write anything here. Then simply click on data, or you can write again data and click on this one. Then simply take data equals to 1 to 10. Here it means that here I am writing this one is the function, base function of the R. So here I am generating the value from 1 to 10. So it will become 1 to 10, generated 1 to 10. Okay. Then here I am printing this one. Either you can write this one or simply write print. Print data. Okay. Print data, then run. It gives same results. So here I am written the capital D, but when you type the small d, a small d, then it doesn't run. Actually, I have the name of data in the environment. That's why. So I am removing the all the objects in my system. Then actually this one is the data, and here I am taking the small d. Okay, so when you run this one, so see this one, the error comes because data is not the part of the small d is not the part of the this one. I have written the capital D and here I have taken the small d. So this one is the difference. Actually, you write the data one and you see the data one here. Then you can see the clear difference. See, the error comes, error in print data one, object data one not found. It means that the object data one is not present in our environment. When we write here capital D, so you can got the results 110. So first you can see the R is a case sensitive language. So before defining any variable in R, it is important to see you are using the capital letter or the small letter. So just like R, I am just calculating simple calculation. So I am defining the Z. Z equals to X plus Y. X plus Y. Here X equals to 20 and Y equals to 10. Then when you run this one, X plus Y, sorry, X, then run Y, then run X plus Y equals to, then you can see print Z, then you can see the results is 30. Okay, this one is the basic operation. Suppose if you want to subtract this one, X minus Y, then it will come the results of X minus Y. Like that, you can multiply, add just like a calculator or in other programming language you can use. So yeah, I am showing the PPT also. Types of data. Actually, in data structure in R, there are mainly 4 types. If all values are same, then it may be vector or the matrix. And if there is mixed value, there are some numeric value or and some is the alphabetical value. Then it is if it is linear, then this will be the types of list. And if it is the in the form of rectangle, then it is the data frame. So this will be operators in R. Is used for the abstract sign is used for the multiplication. Sign is sequence. This one is the exponential. And this one is used for the extraction of the any object. Okay. So then come to the packages. So actually the basic function of the R is the R packages. If there is no packages in R, so it is very difficult to operate any statistical analysis in R. So you can say R packages is the backbone of the R software. So actually this one R is the of the freely available language, the free language. That's why there is so much development in R packages. And the repository, the name of the repository where all packages are stored, or from where you can access the packages, is the CRAN. Actually, this one, the CRAN is the repository. So, and packages also provide wide range of functions and the data sets. So then come to the next come to the how to install R packages. So see here, this one. So there are two ways to install the R package. The first one, simply write install dot packages, and here you write the name of the package. Like here I am writing ggplot2. ggplot2. Then simply click on this one, run. Then the installation of our ggplot is started, and it will. Okay, actually, in my system, the ggplot2 is already installed, so this warning message comes. So the second way to install, second way and very simple way to install R package is go to here, this one, packages. Then click on this one, then click on install. Here I am telling once again, go to this one, packages, then click on install. And here you can see install from where, repository CRAN. Here by default it it takes CRAN. CRAN is the major repository for the installation of R packages, for the storage of R packages. You can suppose that if you have R package dot R package, and in your system, from there you can also install. In that case, you can use package archive file, .zip file or .tar.z file. So almost all packages, all useful packages are available in CRAN. And here you can simply write the name of the package. You can just start to writing ggplot. Then you can see here it automatically comes ggplot2. Then click on install, and kindly don't forget to check this one, install dependencies. If you don't install the dependencies, then in many cases it is very difficult to run and and it may appear several errors. So by default, click on all install dependencies. Kindly check on this one. Then simply click on install. Then it automatically installs. There is no requirement of writing any codes for the installation of the package. Okay. So actually, I have already installed the. If you want to try in your system, then you can try. Okay. So suppose that if you don't know the package is installed or not in your system, and then what is the way how to know the particular package is installed in your system or not? Okay. So from here, go to simply click on this one, and here you write this one, ggplot. Then you can see here it automatically comes ggplot2. It means that when you appear disappear, then you can say the particular package is installed in my system. Okay, then see this one. One more thing, if you install RStudio, then you can from here you can maximize or minimize. You can use minimize or maximize, and you can drag also this one. And in a similar fashion, you can use the left panel, the area requirement on the left or the right panels. You can easily change. So this one is the ggplot2. Actually, here why I am describing ggplot2 and I am taking the example of ggplot2 is that actually ggplot2 is one of the most important package for the graphics. And suppose that if you want to create a beautiful graphs of any types of data or any types of plots, and then in that case without ggplot2 it is not possible. So it is very useful and very important package for the graphics, for the plotting, and there are so many functions. Actually this one is called functions. All these are functions. If you open any package, then these are all functions, and this one is the description of the particular functions. I once again tell, these are all functions and these are the descriptions. Suppose that if you want to see the brief about the particular function, then simply click on this one. See this one. So here, this one is the name of the function, AES. AES is the name of the function, and this one is the name of the package. From actually this one is the name of the package, and this one is the name of the function, particular function, and this tells the works in the simple words. You can tell what the function does. What is the work of the function? So AES function used for the construction of the aesthetic mapping. Okay. And this one is the description of the a particular function. This is the usage. Actually, if you learn how to install package and how to use particular function, then in R it is very easy to analyze any types of elements. There is no requirement of so much programming skills. You can simply learn how to install the any package and how to use particular function and what is the use of particular functions and use of arguments like parameters. How we can change the different arguments. Then this one is the arguments. I will show in the letter how these arguments change. And in the last, this one is the examples. In the simple function words, then simply copy and paste here. Control V. Then click on this one. Then actually this one is the aesthetic mapping. I will show a very good example. The use of the function. So this one is the basic function. In the similar fashion, you can see there are so many functions. So I am taking the another example, which are most commonly used package for the analysis of agricultural data. Is For this, first go to the on this one, agricole. Yeah, this one. So
Dimple Verma, please mute yourself.
So, in R for the analysis of agricultural data, Agricole is one of the most important package. Know the different functions of the Agricole package, then you can do the several and generally almost all common analysis in R. Like that, for the plant breeding persons, everybody do ME analysis, or the different types of plots like bar diagram, histogram, like that, and different types of correspondence analysis, coordinate analysis, and then GG plot, etc. All analysis you can do. I will show some examples from the Agricole package also. So see this one. Suppose that in your system there is a the Agricole package is installed. In that case, first go to the packages, then go to the install, then here you type Agricole. Okay. Then left the all dependencies. Then simply click on this one. Here once again I am installing Agricole for the demonstration. See. Okay. Actually, it will take only few seconds, or if your internet connection is good, then it will take very few seconds for the installation of any package. So it the Agricole package installed. Okay. So after installation of any package, yeah, I am writing. For the installation of any package, after that you import the library. There is for the use of any function, there is two things. First, installation of package. For the installation of package, you can follow the simple step of this one. After installation, to import the library in the environment of RStudio, there are two ways. The first way, simply write Agricole. Suppose that if you want to import the library of Agricole in the R environment, in that case, simply write Agricole. Then see here the checkbox. This one is by default, this one is unchecked. When you click this one, check, then you can see automatically write the library. It means that library is imported in your environment, working environment. And another way to import the library in the working environment is simply write library. Simply write library and the name of the package. Suppose that here I am writing the Agricole. And click on run. Then here I am just showing first I want uncheck. Then you can see here, you can see on this one, when I run it automatically checked. See on this one, then see this one is automatically structure. So for the installation of any package, there are two ways. Either you write the command, then run, or either from here you can easily install any package. So then you want to see the different functions of our Agri-Cole package, any package. So here I am showing the different commands of the Agri-Cole, different functions. So this will take from alphabetical order. Then these all, as I earlier told, these all are functions, and this will be the descriptions. Okay. So here, when you click on, suppose that many genetics or in the many genetical analysis in the plant breeding experiment, the most common is the type of analysis is ME analysis. Okay. So if you want to do ME analysis, then simply click on this one. Then the different description of ME analysis comes here. The first is ME. ME is the name of the function, and Agri-Cole is the name of the package. Okay. Kindly unmute yourself.
And sir, please disable the annotation because everyone dragging the line here, so we can't see all this.
Yeah, this one is not a good practice of the participant. Okay, then the many participants know what is ME analysis. Actually, in the plant breeding experiments, the ME analysis is the most common analysis. So this one is the description. This one is the description of the ME analysis. What is ME analysis? Then additive, main effect, and multiplicative interaction models. This one is the full form of the ME. And it is widely used to analyze main effect and the genotype by involvement. Gene to E interaction you can see using the ME analysis. So this one is the theoretical part. Then come to the practical. Then this one is the usage. How the ME function you can use. So this one is the usage. This one is the different argument present in the ME functions. Suppose that ENV. Here you can see the capital ENV. ENV means environment. Here you can see the description of the different arguments. Then the GEN represent the genotypes, REP represent the replication, Y represent the response, MSE is the mean square error, and console output. If you want output in the console or not, then you can put either the true or false. Either you can write in the full true, and the true you should write in capital, not in small. In R, it take in the capital like that, like true or false. And this one is the PC, principal component or true or false. Then these are different arguments which you should provide in the for the ME analysis. Then comes to the value. Value represent the different outputs. When you run this one, when you run the ME analysis, then the output comes. Then these different parameters come in the form of output. Like first one is the ANOVA of the ME model. Then G into environment interaction analysis, means biplot, and PC. This one the biplots automatically comes after the running the ME models. And this one is the description, basic descriptions. Then this one is example. Suppose that if you want to use any function or any model, then it is very good practice. First, you use the simple example. After that, you should take your own example. Okay. So here you can see the library is Agricole. First here first you install the Agricole package, then import the library. Then this one is the data. PLRV is the inbuilt data of the Agricole package. Okay, so I am showing the how it will come. Here I am copy and the paste. Then first attach the data. Then after that I will show how to import the data in your environment also. So then I am using the ME models. Then simply run the model. Then yeah, one more thing I want to tell. Actually, in the model is the object. You can write anything in place of model. And in model, here I am writing the model. When you put the this one $sign, then you can see all these values comes. If you want to Innova, then click on Innova. Then if you want to G into interaction, then click on this one. Then if you want to analysis, means, biplot, PC, then you can suppose that here I am clicking Innova, then click on this one, run. So see, this one is the Innova for the ME analysis. Okay. So in the Innova, see, this one is the environment, then replication. So genotype and genotype into then finally the residuals. Like this one, you can use the ME analysis engine. Then suppose that if you want to extract, and suppose that if you want to all things, then simply click on simply run this one model, then run. Then you can see all things, all objects have been given output. First Innova, then the G into E interaction. Output comes. Then different types of PC. The principal components comes like that. Okay. And if you want to do particular, actually, yeah, I want to do one more thing. Suppose that if you want to delete all these things in the environment, in the console, then simply click on here, this one. Then it automatically erases all things in the console. Then here you put the $sign, then means. Then click on runs, then it gives the means. Like that. Okay. So this one here the data is PLRV. PLRV is the inbuilt data of the in the Agricole package. In the similar fashion, you can use any types of analysis. You can do CRD, RVD, LSD, and all types of different types of Innova in this. I will show see here. This one is the fitting of the design of experiment for a factorials, alpha designs, randomized valence, incomplete design, completely randomized design. If you want to do analysis of the CRD, then use the design dot is used for the CRD. In the similar fashion, you can first you can run the simple command. After that, import your data. So one more thing I want to tell, importing of the data. I am writing how to import. One of the most important things. Many people tell this will be the simple example. Then how to import the data is the important things. Then here I am writing import the data. Okay. So in R, for the importing of data, there are so many ways from where you can import your data. Okay. So the first way to import the data is from here. One simple way and very easy way. If you don't know any line of command, then a very simple way is import the data from here. You can see here in this import data set. Then first you should click on environment, then click on import data set. So here comes import data set from which type of files, from SPSS file or Excel file or .csv file, like that. For that, if you want to import data from Excel file, then simply click on Excel file, then the window appear like that. Then select your file. Actually, I have already created a simple data file for the demonstration purpose. So here I am selecting and I put the data in the desktop. Go to the desktop. Then I am writing simple data dot XLS X. Okay. Then simply click on this one. Then data came here. Then simply click on import. Then data are imported, and the name of the data is simple underscore data. Okay. So if you want to see the data simple underscore data, then click on this one, run, then the data automatically come here. So want to see only few observation of your of the data set, then simply write head simple data. Then see only few observation come here. Like here in the data set, the first column is genotypes. Then there are three variables: FM, PV, and TP. Here I will show the data. This one is not. Actually, this one is the data set. The first column is the genotype, and there are three more variables. So one way to import the data is from the import data set options. Okay. The second way to import way to import the data set, line some a small command, and either you can save this command, and you can end again. Simply write read dot if you want to import the data having Excel file, then read underscore Excel. So actually for the importing of data using Excel, there is not a default, the function of R. So for importing the data using Excel file, first you install the package read Excel. I will show the name of the function. If you don't install and import the library of read Excel, then in that case you will not able to import the Excel file. So read Excel. Read Excel. Yeah, this one. Read Excel. Or one more package is also you can use one more package that XLS. The name of the package is read XLS or XLS package. But either you can use this one or that one. Both are same functions. Only a small differences. After that, all things are same. No problem. So this one is very easy to use. You read Excel. Then simply click on this one, install. Then after that, you can simply import your data. So here I am show the package of read Excel. See here, this one is the package read Excel. So there are different functions of read Excel also. Suppose if you want, you can see in Excel file there are two things. In the older version of Excel, the file name is with .xls, but in the newer version of the Excel file, the file extension is XLSX. So if you have confusion, in that case, you can simply use read_Excel. And if you already know my file XLS or X, in that case, you can use any type of either the XLS or XLSX. Okay. Then after that, here you write the read XLS. Here I am writing the simple letters. Simple. Actually, I am creating an object. Simple equals to, either you can simply write the equals to sign, or simple equals to read_Excel. Here you write choose files. Okay. Choose.files. Then run simple command. This one. Run this one. Then after running, you will see a window open, a window automatically open like that. This one. A window automatically open. From here, you can simply select your data. Simple data XLS. Okay. Then data has been automatically imported in the environment. Then if you want to see the data, then simply write simple, then you can see the data have been imported in your environment. This one is the two techniques for the importing Excel file to the environment, our environment. Then suppose that if you have, yeah,
I have a small doubt.
Yeah.
Can we import the data with multiple sheets in the Excel file with the same code?
No, at one time you can select one sheet.
Okay,
Yeah, if you see here, if you have any more, if you know the functions of _Excel file, then simply click on this one. Then see here the different functions of read_excel functions. Okay. So this will be the path sheet. If you want to import the particular sheet, then you select the sheet here. Okay.
Okay.
Like that. And one more thing, you can simply write headers equals to true. Either you write or by default it will take true, or you can write header. Actually, I think that this function is not works in read.excel. Okay. So these two ways to import the data in RStudio. And suppose that if you have data in .csv file, many types of large data are in .csv file. In that case, simply write here. I am writing defining an object sample1. Sample1 equals to read.csv. Read.csv. Choose.files, then run. Okay. It will automatically either it automatically come here, and if not come, then simply minimize RStudio, then you will see from the desktop or where you have located your files, you can import your data in the CSV format. Okay. Suppose that if you have data in the text format, that in that case you can simply write like that. Yeah, I am copying. Here you can simply write read.txt and select the text document file. In that case also, actually this command choose.files and colon is used for the opening of new window for selecting any types of data. So here I will give brief about the importing the Excel file, .csv file, .txt file. And if you want to import more types of files, then you can simply use from here, from SPSS file or SAS file, from a Stata also you can import your data. But these three are most commonly used in the experiments. Okay. Then come to the how to export your data. Suppose that I have a data, this one, sample.1 I have already imported, and I want to export or data or any types of results. I will show in the exercise also how to import. For the exporting of any types of data, simple write dot suppose that if you want to export the data in the form of CSV file, then simply write.csv and the name of the file, and my name is simple, then file equals to put colon. Then what you want to give the name of the file, from where it will store. Okay. Then here I want to give the simple data or simple data .csv. When you use this command, then you simply import the data. Just I will show, then click on this one. So if you selected the working directory, in that case the data will be stored in the working directory. If you don't select any working directory or don't use the working directory, in that case, the data or the object which here I have created is stored in the document file. So simply from the file, open the documents. See here, I've already opened the documents. Click on documents and see here, yeah, sample data. Here you can see the stored sample data has been stored. And if you want to see, then here from here I have deleted. Once again, I run the code. Then you can see, yeah, sample data has been imported here. Okay. This is the simple data which I have imported or which I have exported, not here in that case, not imported, here I have exported. So any types of results, analysis results exported in either in the TXT format or the CSV file format or Excel format, also you can export your results. So next come to the, I think that this one is about some brief about the R and then R Studio, then different types of packages, then how to import the library, different types of functions, then how to import the data in the system, then how to use the different functions of any package. Then next come to I have taken a practical example to show a simple basic analysis, how to plot, how to give the descriptive statistics of the data. So here I have taken an example of iris data. Yeah, here I want to tell one more thing. Suppose that if you have, suppose that you know the name of the package, and you want to explore more about the that function, particular function. In that case, suppose iris is a data set, okay, and iris is a function also. Iris is a function also, and if you want to know the function iris. So simply write here question mark. Simply write only question mark and write iris. Simply write iris, then put enter. Then see here. So the description of the iris has been appear in this section. Okay. Like so like any other functions, like if you want to do earlier, we had been seen about ME analysis, and I want to open the ME analysis, then simply write ME and put enter. Then it automatically open the ME. Or suppose that if you don't know anything and and there is no information about the particular package or the particular function, in that case we will put the double question mark ME. I am writing simply ME. Okay. Actually, if a particular package is installed in the system, then put simple question mark. Then it directly open the particular function. And if you don't know anything, then put double question mark. Double question mark either put here and run, or you can write here and run. Both give the same results. So see ME here I am write the ME. Then we will see ME, the name of the function ME. So see This one is the ME for the Agricole package. I think that no others package use the name ME. So from here, you can see here, and then one question arises: how to know the particular function is used for the particular analysis. To know any types of analysis, simply write in Google like the principal component analysis in R. Then you simply write in Google principal component in R. Then it will give the brief description and so many codes, R codes. Simply copy and paste here, and simply that code you should simply manipulate that codes. Then you will be able to do very good analysis, because it is a very vast resources. So for the real data set, I will show an example analysis of Irish data set. So first I want to tell what is Irish data. And I think that many students or many participants may know the Irish data set. So here I am simply run this code. Irish data set. This one is actually the Irish data set, which is inbuilt in R software, and it is very well known data set. And in R or Python or many programming language, this data set is used for the illustration purpose. So this one is the description of the Irish data set. So you can see here this famous this data set is generated by Fishers. The Irish data set give measurement of the measurement in centimeter of the variable sepal length, sepal width, petal length, and petal width respectively for 50 flowers from each of the 3 species of iris. Iris Cenota, vesicular, and versigelia. Okay. This one is the description of the data. So this one is about brief about the format of the data, which is already inbuilt. You can see this R, so it will automatically gives. So this one is the source. The source is R.F. Fisher, 1936, and this one is the use. So I will show what is the data and how this standard data is used in the analysis. In the similar fashion, you suppose that if you have a data, then in the similar fashion you can do any analysis after importing your data in the RStudio. Okay. Then so before the analysis of the Irish data, first you should install all these packages. You first install, then import the library. First check either if the package is installed or not. If the package is not installed, then first install, then import the library of all the packages. If any package left, or if you don't import any library, then error will come. Okay. So for installation, I have already told how to install. Yeah. One more thing I want to say. Suppose that if you don't want to run this line of command, then simply put a hash. Simply put a hash. Then these are the comments line, become comments line, not the code. This will become the comment line. Okay, so for the installation, you either use the install.packages, and here you can write the name of the package, or either you go here, simply click on this one. Here you write the name of the package, tdverse, PIDY. Then click on install. Then it simply install. So actually, in my system, all these packages has been installed. So there is no requirement to install once again. So if you want to use, and I will share all codes also, all of you. I will give to Kapil, and he will share all of you. So first, you want to run one by one, or if you want to select once go each chunk of command, then click on this one, run. So all library of the all 5 packages has been imported in the environment. Okay, so this one is the iris data. So simply click on iris. The name of the data is the iris. Okay, so the iris data contains the 5 columns. The first one is the sepal length, then sepal width, then petal length, then petal width, and the last column is the name of the species. And here there are 3 species: Setosa, vesicular, vesicular, and this one, Virgin Asian. Okay. Then this command is used. Suppose that if you want to import the data in your system, sorry, export your data in the form of CSV, then you can simply write this command, write.csv. Here I am importing the data in the form of CSV. So here I write.csv, and this one is the name of the object. Here the object is iris, so this one is the iris. Then the name of the file, from which name actually I want to store the data in my working directory or in the document. Okay, so when you click this one, write.csv, so simply go to the document. Document. So see here the iris, yeah, this one. The iris comes. See, this one is imported in the form of .csv, and here you can see there is 5 columns of the data. So this one is the serial number, sepal length, sepal width, petal length, petal width, and the name of the species. So this one is the data set, and there is total 151 observation. Yeah, sorry, 150 observation in the data, 50 each. So first I want to show the basic structure. Suppose that if you have data, and if you want to know the basic structure of the data, this one is the very small data, so you can easily see in the Excel also. Suppose that if you have a very large data set, and so in that case, you can and if you want to know the number of row in the data, so click on this one. The n row is used for line for the know the number of row. N means number, row. N row is the function which is used to know the number of row in the in the particular data. So after that, when you run this one, n row iris, so this gives 150. It means there is number of row is 150 in the data. And here I give the annotation what this function gives. Either you can put here after hash command, either from here you can cut and paste. Okay. So after hash, this is long. This one is not required. This one is the comments line only. Okay. So this gives the number of row in the data. Okay. So ncol iris is my data set, and ncol gives the number of column in the data. So when you run this one, it gives the number of column in the data. So the number of column in the data is 5. So after that, I want to know the class of the data. So simply write class iris. So it gives data frame. It means my data is data frame, not matrix, not vector. My data is data frame. Okay. Then names iris. Simply write names and you, the name of the data. You can define any name of your data. So simply write names iris here. Then it gives all the 5 names of the column. First one is the sepal length, sepal width, petal length, petal width, and a spacing. So after that, if you want to give more information or more structure of the data, and so you simply write str iris. Then when you run this command, then see this one is the data frame. The type of the data is the data frame. It contains 150 observation and total the 5 variables. These are the variables. These are the variables, and these are the numeric value. The 4 observation is the numeric value, and one is the character. The last one is the name of the species in the form of character, and this one is the sum values of the data. It gives in the single command. It gives the all properties, different of the basic property of data. Then alternative way to give the information of the data is simply write glimpse iris. You can simply run this command glimpse iris. Then it also gives the number of row, number of columns, sepal length, sepal width, species like that. Suppose that if you have a very large data set, and if you want to show only few observations, like 4, 6, 10, or 20, in that case, you can write as under head, and this one is the name of the data. In the place of iris, you put the name of your data, the object name of your data, and 10. Here 10 indicates it show the first 10 row of the data. So if you run this command, then it gives, see here, it gives the first 10 observation of the data. Because if you have large data set, then it is not possible to see in the console window to see all the observation. It is very difficult. So first you should know the first 6 or 10 observation and the last 10 observation to check the to check my data is correctly imported in the R Studio or no. So this one is the this command give the first few observation. This command here you can from head, and here you can simply write tail in place of head. Then it will give some observation. And if you want to know the more observation, like 12 observation, then simply write here 12. Then it will give the first 12 observation. See? Yeah, see this one. If you want to know the last, last 12 observation, then it will give the last 12 observation of the data. So here you can see in my data set there are 5 variables, and I want to extract the particular variable. Then simply write here you are creating the sepal or any other object, or you can write sepal1, or you can write sepal length. You can creating. Then write equals to sepal. Here I have written sepal equals to iris. Iris. Then this will be the large bracket, and put the column name of the column. This one is the, here I am writing the first column. See, the sepal length is in the first column. So you can if you run this one and see the sepal, then you can see the first column, that is sepal length, has been extracted. So you can use the sepal length. Then I want to extract sepal width. Then here I am writing sepal W. I am just writing sepal W equals to iris bracket 2. If you put 2, in that case it extract the sepal length as well as the this will extract the sepal width. Run this one. See, this one is the sepal width. And suppose that if you want to take a sepal length as well as the sepal width, then simply write B. Then here I am writing 2 like that. Then write 1:2. It means that 1 to 2. Suppose that if you want to select the first 3 column and left out of column, then simply write 1:3. Then data after that I run this. This gives first 3 columns. Okay. Sepal length, sepal width, and patterns. Then one way to extract the data is using the bracket, and the second way is used to use the dollar command, $sign, like that. See here. Here I am putting here I am creating the object summary like that. Then summary equals to describe. Then data is iris. After that I am putting the $sign, and after that we put the sepal length. And the sepal length. So see this one. So if you run this command, it will also give the sepal length. 1 minute, I want to zoom. See here. If you want to see the variable sepal length, then it gives the descriptive statistics like that means n gives the number of observation, means is 5.84, standard deviation, median, trimmed, mean, minimum, maximum, range, skewness, kurtosis, and standard error. It gives the basic description of the variable sepal length. If you simply write actually here I'm also created the sepal, then you can also simply write sepal. It gives the same results. See, it gives same results. Okay. So then if you want to know the descriptive statistics of the petal length. So in the similar fashion, put the command iris $petal dot length, name of the variable. Okay, it gives the So next come to the data visualization.
Excuse me, sir.
All of you kindly mute yourself.
Excuse me, sir.
Yeah.
Sir,
tell
we
me.
don't have file, so we cannot understand this procedure.
Which file you don't have?
It is going over the head.
Iris data. Okay, actually I
Yes,
will
sir.
share, no problem. I will share all these codes. Okay. After the class, I will share all these code, and definitely all codes will run. No problem. There is, I think that there is no error in the course. Okay.
Sir,
Sir,
we
we
don't
will
have
provide
file.
recording, both recording and the code as well as after the session over. So actually, don't worry about this.
Sir, we
Thank you,
don't
sir.
have file.
The recording also.
Yeah, if you will share recording, then it will be better, sir.
We will send.
Actually, ma'am,
Yeah, sure.
recorded lecture will be means we will send you after this session.
Yeah,
Maybe-
sure, sir.
So we know this is a little bit complicated for initial
Yeah, this
phase,
is
but
literally, yeah.
yeah.
If we will
So
see
don't worry,
recording,
we
then
will.
we can understand properly.
Yeah. Definitely, we
Yeah,
will
thank
send it.
you.
Okay.
So if you want to see the normality, check the normality of the data, whether my data is normally distributed or not. Then I think that many people know there are different tests to check the normality of the data, like Shapiro-Wilk test, Anderson-Darling test, Q2 plot, PP plot test used for the normality of the data. Here I use the Shapiro-Wilk test for the this one to check the normality of the data. So simply click on this one, Shapiro dot test iris and the sepal dot length. Either you can put the particular column of the data in place of iris dollar sepal dot length, or you can put in this manner also. So when you run this one, so see here, this one is the test statistics value of the Shapiro-Wilk test of the normality. So this one is the W is the test statistics, and this one is not so much important, but main important thing is the p-value. So here you can see the p-value of the Shapiro-Wilk test of the normality is 0.01. So the value of the test statistics is the less than 0.05. It means that our null hypothesis is rejected. So and the null hypothesis of the Shapiro-Wilk test is our data is normal. So our null hypothesis is rejected. It means that our data is non-normal. Means the sepal dot length data is not normally distributed. Okay. Here I want to tell once again, the p-value is less than 0.05. It means that this one is not significant. So the null hypothesis is rejected, and the null hypothesis is our data is normally distributed. So the null hypothesis is rejected. It means that this data is not normally distributed. Okay. So next come to the plots. So here I am plotting. Use the simple function. If you want to see the basic plots, then the plot function is used, and this one is the two data sets. This one is the first one is the sepal length and the petal length. And I have already told the dollar sign is used for the extraction of particular column of the data set. So in this case, you can extract the petal length, and in this case, you extract the in this case, you extract the sepal length, and in this case, you extract the petal length. So if you want to plot of both sepal length and petal length, then simply click on this. See, this one is the plot. In the x-axis, this one is the sepal length, and in the y-axis, the petal length. And here I have taken example for the illustrative purpose. When you use in yours data, original data, then actually it is better define this one first. After that, you put you can use here I will show first sepal. Like that, sepal L, I am writing equals to this one. And actually, here I want to show the name of the axis, how these axes become change after defining the variable. See, in the earlier plot, this one is the name of the axis is this one. After that, when we plot this one, see the name of the axis become changes. Okay. So if you want to give any name, then accordingly you put your name in the data set, and accordingly it will change. Then this one is the sepal length and petal width. This is the plot of the sepal length and petal width. So actually dollar sign after the is used for the extraction of the particular column of the data. Yeah, this one is used for the QQ plot for the test of the normality. So this one is the QQ plot, and here I want to put a line. Yeah, see, this one is the line. So in this case, you can see in the QQ plot, there are so many observations which are not in the line and not the symmetrically distributed. So you can suppose that all the observations are in the line, all the observations are in the line. In that case, our data is normally distributed. And here you can see the many observation is out from the line, and here you can see also few observation are in the form of outliers. So after the visualization of the QQ plot also, you can tell our data is not normally distributed. So next come to the box plot. See this one is the box plot. Box plot, this one is the name of the species, Setosa versicolor and Virginicea. And in the y-axis, there is the sepal length. So this one is the plot. Simply write the box plot. Iris. This one is in first you write the length, then the species. Then this one is a Tinda sign. After that, you write the species. Then you got this type of plot. Suppose that if you want to zoom this plot, then you simply click on this one, zoom. Then see this one. This one window open, zoom. And suppose that if you want to export any figure or any plots from there, then simply click on export. Then click on copy to clipboard. Suppose that if you want to save image in the form of image, then simply click on this one. Then simply click on save. Save, then particular location from where you want to save, then it will come and figure and you can store the plots anywhere in your system. Okay. And if you want to copy and paste in your Word document, in that case, and if you want to change the axis, then it looks like the width is low, then you can simply increase your width also. Like here, automatically it comes 692. In place of 692, you can put here 800. In place of here, you can put the 600. Then update preview. Then you can see the plot automatically increases the size, and the copy plot and paste it and simply paste in the Word document for the exporting any plots. Then comes the box plot of the sepal species. So this one is the sepal width and the different species. Then come to the histogram of the iris sepal length. So I want color in the blue color, dark blue color, and border is yellow. Here I define border is yellow. Here you can define border is yellow, red, green, any color. So when you run this command, then see the plot, the histogram plot of the sepal length comes. This one in the y-axis there is frequency, and in the x-axis our variable sepal length. So suppose that I want to change the color of the plots, then simply click here and run. See here actually I defined the color is dark blue. Sorry, the color is dark red and the border is green. So the border comes, this one looks like green, and the main color is red. You can simply write, if you want to light color, then simply you can write red. and border is green or dark green, you can change automatically according to your requirement. And all these plots are happening due to the ggplot. So ggplot histogram showing frequency count of the variables sepal length. So here I have showing this one. So here I have written the fill equals to white. So that's why this type of plots comes. Here you can write fill equals to red, then it will become red or yellow. For more information, you can search in Google also how to change color, and the color this one is black. You can use different color also. You can change your color also. Then come to the this one. I want to change the color. Yeah. Suppose that this one is the plot of simple plot in the vertical manner. Suppose that if you want to convert the axis, and then if you want to plot in that case, simply write the command flip chord underscore flip. Then it automatically flip the diagram, the plot. If you want to see in the zoom, then simply click on this one. And I have already told for the exporting the plots from here, you can export in the different format. If you want to save in the PDF format of this plot, then click on this one, and in the image format. And if you want to paste in the Word, then or PPT, then you use this command. Then in the similar fashion, here I show one more example for the petal length. Here this one is for the sepal length, and here I will show for the petal length. This one is the histogram plot of the petal length. So this one is the horizontal plot of the petal length. And this one is the group count. In the single diagram, I will show all things like red indicate the setosa, green indicate the versicolor, and blue indicate the vesicolor. This one is the sepal length. This one is the count. In the single histogram here, I will show all the 3 species. So this will be the flip of the previous diagram. Yeah, one more thing I want to say is, suppose that if you want to show the to view the previous diagram, then you can simply click on this one, this command, this one. Then all the image comes here. Then if you store one time, and you can save at any time, at anywhere. Okay. Yeah, this one is the frequency count in the single diagram in the different manner. In the earlier diagram, we will see in the different format. In the like of single histogram, you will see in this the difference is like that. This one show the frequency distribution of the setosa. This one indicate the frequency distribution of the versicolor, and this one indicate the frequency distribution of the Virginiaceae species. Then, yeah, then comes to the density plot. So in many papers, many research papers, you will see the different density plots. If you want to plot density plot, then use these commands. So this one is for the sepal length. Then this one is for petal length. This one is the plot of the density plot of the petal length. Then in the single figure, the density plot of the all the three species of the sepal length. In a similar fashion, you can plot for the petal length, petal width, and sepal width also. See, this one is also the in the similar fashion. I have plotted the density plot of the petal length. This one is red indicate the setosa, versicolor, and virginitia. Then box plot of the sepal length. Then in the previous diagram, there is no color fill, and so here I put orange color. Similar, you can put the red color or green color, any color you can put. So last, see, this one is the box plot of along with the distribution of the observations. This indicate how the observations are distributed. So this one is for the setosa, this one is green is for the versicolor, and blue is for the this one virginitia. So this one is about the something brief about the R software, and have any question, then you can ask. I will take I can take few questions if organizer permitted. Okay.
Yes, sir.
Yeah, Kapil.
Sir. If anybody have any query regarding this one, so they can ask.
Good afternoon, Rajiv.
Yeah, yes, sir.
Rajiv, good afternoon. I'm Alok from IITR.
Yeah. Look. Good afternoon.
I just want to know the format. What is the format of data for the particular analysis in R? Like if we take 4 application and in one column it is genotypes, in other column it is replication of the traits. How we know the format?
Yeah, very good question. Actually, the different package requirement different formats of the data. According to the requirement of the particular function, you should arrange your data yourself. For this, you first see the format of the data on which the sample file run. For this, first go to the package, then go to the particular function, then see the format of the data in which they take. For example, I am showing. Sorry. Actually, I am not able to share my screen. So
No, sir.
actually,
Now you can share, sir.
yeah, suppose that earlier I have explained the Agricole package. Okay. Agricole package. I have do the ME analysis. Okay. So you can see here the format here in this example they use the data PLRV. Okay. So see the data PLRV. Okay. So according to this format, you arrange your data. So this one row, the genotype, this one column indicate the locality or the environment, then replication, plant width, plant height. This one is the very name of the.
Could you please again explain the same things? How we know?
Yeah, okay. I tell you once again. Actually, in R, different function require different format of the data. So to see the suppose that if you want to do a particular analysis, in that case you should arrange data in the particular format. Okay. So then the question arises, how I want to know the format of the data. So first I will go the analysis. Suppose that I want to do ME analysis. Then for the ME analysis, how I can arrange the data. So simply click on ME. Here I actually know the function. So simply click on this one, ME analysis. Then go to the last. Run example. This one is examples. Okay. So in this you can see the data used is PLRV. Here in this package, the developer of this package used the data PLRV. Okay. So this should see the format of the PLRV dataset, and the format of the PLRV dataset. Then once again I will show. Then how I will know the PLRV dataset? Then simply copy this one. Simply copy this one. Then paste here. Then put enter. Okay. And then simply write PLRV. Okay. Then you will get the data. PLRV data. This one is the format of the PLRV data. Then accordingly you arrange the data according to this.
Thank you, Rajiv.
Yeah, any other question?
One more question I have, Rajiv. You have mentioned that for finding the code, we just search the code in Google and accordingly we manipulate as we want to analyze the data.
Yeah.
Could you please give example in Google to search, how to search and how to manipulate the that code according to our analysis?
Okay, sure, I will show. Just I am just give me 1 second. Here once again I am using the example of ME analysis. Okay. Here I am writing ME analysis in R. See, so there are so many help file comes like this one. This one is the full description like that. And if any help from the net, then you can simply get the help for the particular package. Then you can see here I simply write the ME analysis in R. Then it automatically opens several pages. From here you can copy these tabs of code and paste there. Then simply manipulate according to your requirement. And I am doing one more thing, principal component analysis in R. Okay, I am writing. So we will see there are so many ports, different types of ports. This one, like that. First install the package dplyr, loading the library of dplyr, a structure. Then it will give a very good description how to perform PCA. Okay, like that. This one is the course, or you can find any other package also, like this one. Yeah, this one is used print comp function. Sorry, yeah, for use the principal component analysis. This one gives the very good example and very good description for the how to perform the principal component analysis in R. Okay. In that manner, you can search. Actually, if you know some basics of the R, then you can easily do. Okay.
Excuse me, sir.
Yeah.
Sir, I am
First
student of Punjab Agriculture University.
Yeah.
Sir, we are very interested in our software, but due to don't have any Excel file for tomorrow's session. Before this session, please provide Excel sheet or a PDF file.
Okay. Actually, after the session, I will send it to Kapil. After that, he will share it. Okay. All codes as well as simple Excel
Sir,
file.
also for tomorrow's session.
Hello, as you can see, na, Rajiv said today did not import any Excel file. Actually, he used Iris data, and Iris data is already inbuilt in R. Actually, he imported from R software only. So tomorrow
Actually,
maybe.
Actually today for today exercise, I don't use any imported file. I used already the file which are already available in R inbuilt.
Yes.
Inbuilt R. Iris data is inbuilt in R.
So maybe tomorrow's speaker also can use the inbuilt file. But if you are interested, then you after watching your recorded session, you can use your data as your wish.
Okay, sir. Thank you.
Okay.
So, Rajiv sir, I express my sincere gratitude for your wonderful session you delivered. Your expertise, knowledge, and passion were evident throughout, and it made the session truly exceptional. You covered all the very basics about R, how to import, export files, what are packages, what are different, how to install them, everything you have explained in detailed manner. So after this session, we will definitely share these recorded lecture to all the participants. So actually, for beginners, initially it is little bit complicated, but we will share recorded lectures so they can practice as well. So thank you very much, Dr. Rajiv Ranjan sir, for this wonderful session.
Thank you, Vijay.
Okay, fair. Then we will meet at 11 a.m. tomorrow with the new session and new guests. Thank you very much.
Thank you, sir.
Thank you, sir.